Welcome to AulaUE. My name is Maria, and today we are going to see an example on how to solve a system of three linear equations. Let's suppose that we are given the following system of linear equations. X plus 3y plus z equals minus 3, 3x plus 9y plus 4z equals minus 7, and 2x minus y plus z equals 6. And we are going to apply Gauss method. Okay, the first thing that we have to do is write down the coefficient matrix. In this case, we have 1, 3, and 1 for the first part, minus 3, the last part of the first equation. Then for the second row, we get the coefficients 3, 9, 4, and then minus 7, just by looking at the equation. And lastly, for the third row, we have 2, minus 1, 1 and 6, and we need to operate a little bit using Gauss method. First of all, we need to select the pivot row. In this case, it's going to be the first position of the first row, and we have to make zeros just below this main diagonal, basically in these three positions. To do so, we just need to start doing zeros below the first pivot row. In this case, positions 3, 2 must be a 0. And to do so, we just need to operate a little bit. To cancel these 3, we just need to operate with the pivot row, doing second row equals the second row minus 3 times the first row. And to cancel the 2, we just do row 3 equals row 3 minus 2 times row 1. If we do these operations, we just, of course, copy the first row as it is, 1, 3, 1 minus 3, and then operate the second row. It's going to be 3 minus 3 is 0, 9 minus 9 is just 0, and then 4 minus 3 is just 1. In the last position, we have minus 7 minus 3 times minus 3, which is 9, so positive 2. Pay attention to the minus sign. In the last row, we just need to operate as we did before, so we have 2 minus 2, 0, minus 1 minus 6 is just minus 7, and 1 minus 2 is just minus 1. 6 minus 3 times minus 2, it's going to be positive 6, so 6 plus 6, 12. And then we are quite lucky because we have 2 zeros in the second row. So we already have the required number of zeros. We just need to switch the order of row 2 and row 3 to have the zeros below the main diagonal. If we do that, we just copy the first row, 1, 3, 1 minus 3, and then copy the second row as 0, minus 7, minus 1, 12, previous third row. And the third row, it's going to be 0, 0, 1, 2. And you can see that we have all these zeros below the main diagonal. Okay, at this moment we have two possibilities. We can keep on working doing Gauss to find out a solution, or just replace once again the matrix by the corresponding equations. If we do so, we have x plus 3y plus z equals minus 3 for the first part, minus 7y minus z equals 12 for the second equation, and then z equals 2 for the last equation. And you can see that we already have the solution for z. Z must be equal to 2, and we can just find out the solution of the other unknowns by replacing this value into the previous equation. So if you replace z equals 2 in the second equation, we get minus 7y minus 2 equals 12. And if you operate a little bit, you find out the value of y. Y must be equal to minus 2. Okay, at this moment we already have the solutions for both z and y, and we can just find out the value of x by replacing both into equation number 1. If you do that, we can have the solution of x as follows. We have x plus 3 times minus 2, the value of y, plus z, which is 2, so plus 2, equals minus 3. And if you operate a little bit to find the value of x, you find that x is just equal to 1. Okay, so we already solved the system of three linear equations and we got the solution x equals 1, y equals minus 2, and z equals 2. We can put it just as clear as possible here. And of course, one advice always is to check the solution. So check it by replacing these values into every equation, and they must be true, step equation by equation. And that's all. I hope you enjoyed this video.